to investigate what happens when you have exponents that are 0 and negative. So by the end of this lesson, what we want to be able to do is understand the meaning of non-positive exponents. We want to be able to write a number with a negative exponent in a form that has a positive exponent, and write a number with a positive exponent in a form that has a negative exponent. And finally, we want to be able to use negative exponents to represent numbers that are really close to 0 in scientific notation. So before we begin the lesson, go ahead and do the warm-up. Look at the table for y equals 3 to the x power on your calculator and see what happens when you have an exponent of 0 and a negative exponent. So let's take a look at this. We have y equals 3 to the x power. We want to look at the table, so we're going to hit the settings button, convert this to a table. And I'm going to fix this up a little bit. We'll go -3, -2, and then we'll take this down to 3. So if we're looking at this, the first question is what happens when the exponent becomes 0? So if you look at this, we have 3 to the third power is 27, 3 squared is 9, 3 to the first is 3. Finally, you have 3 to the 0 power is 1. So when we have an exponent that becomes 0, it appears that the equation has a value of 1. So what happens when the exponent becomes 0? Y is equals 1. And what happens when it becomes negative? We have 0.33333 repeating, which is 1/3. We have 0.1111, which is equivalent to 1/9. And then finally we have 0.037037 repeating, which is the same as 1/27. So when we have negative exponents, it appears that we get values for the equation. The y values become fractions. Okay, so we have fraction values. So what happens is the y values become fractions and get increasingly smaller. So they're getting smaller and smaller and smaller. They're getting closer to 0, getting close to 0. But never getting there. But never gets there. Okay, so let's go ahead and explore these exponents. So maybe you have, maybe you haven't, but you might have noticed that in this chapter we've only used positive exponents. So we're going to explore what happens when you have a 0 or negative integer as an exponent. So in this first step of the investigation, we're going to use the division property from our previous lesson, where we take where you have b to the n divided by b to the m, and that we know that is equal to b to the n minus m. So we're going to write each of these expressions in that form. So we have y to the 7th divided by y squared. That gives you y to the 5th. 3 squared to the 3 to the divided by 3 to the 4th, you'd have 2 minus 4, which would be 3 to the negative 2nd. 7 to the 4th divided by 7 to the 4th. You subtract the exponents, you get 7 to the 0 power. 2 to the 1st divided by 2 to the 5th would give you 2 to the negative 4th. X to the 3rd divided by x to the 6th, you have 3 minus 6, so that would give you x to the negative 3rd power. Z to the 8th divided by z to the 1st would be z to the 7th power. Then you'd have 2 to the 0 power. You'd have x to the 0 power. This would be equal to m to the 3rd power, and this would be equal to 5 to the negative 2nd power. So you should notice that some of your answers in step 1 have a positive exponent, some should have a negative exponent, and some should have a 0 exponent. So step 2 asks, how can you tell what type of exponent will result simply by looking at the original expression? So if you look at these, and we see that we have a positive exponent here, a positive exponent here, a positive exponent here, you'll notice that for a positive exponent, oops, that you have, the way you get a positive exponent is the exponent in the numerator is bigger than the denominator. And in order to get a negative exponent, it would be the opposite. If you look at this, for letter B, you got 3 to the negative second. The exponent in numerator, so exponent in numerator is smaller than exponent in denominator. And finally, to get a zero exponent, the exponents are equal. They're the same. So, what I want you to do in step 3, and I'm not sure why this has stopped sharing on the video, so give me 1 second to figure that out. It looks like we stopped sharing our screen, so let me fix this real quick. So 1 second. Let's see. Sorry about that. Good thing I caught it. There we go. So again, a positive exponent shows up when you have the exponent in the numerator is bigger than the exponent in the denominator. Negative exponent was when the exponent in numerator is smaller than the exponent in the denominator. And finally, you get a 0 as your exponent when the exponents are equal. So in step 3, what I want you to do is go back to step 1 and take any expression that resulted in a negative exponent and write each in expanded form and simplify them. So if we take these, we have 3 squared divided by 3 to the 4th. 3 squared divided by 3 to the 4th. So if we wrote that out, we'd have 3 times 3 divided by 3 times 3 times 3 times 3. That 3 cancels out with that 3. That 3 cancels out with that 3. And we're left with 1 over 3 times 3, which is 1 over 3 squared. If we take another one, we have 2 to the 1st divided by 2 to the 5th. We'd have 2 divided by 2 times 2 times 2 times 2 times 2. That would be equal to 1 over 2 to the 4th. If we look at letter E, we have x cubed divided by x to the 6th. That would be equal to x times x times x, and then x times x times x times x times x, where you'd have 3 of these x's cancel out with 3 of those x's, and we're left with 1 over x cubed. So compare your answers from step 1 and step 3. Explain what a base raised to a negative exponent means. So if you look at this, you have 3 to the negative 2nd power, you have 1 over 3 squared. You have 2 to the negative 4th power, you have 1 over 2 to the 4th power. X to the negative 3rd, you have 1 over x to the 3rd. So what does that mean? Well, if we wanted to, we could say that it appears that a base raised to a negative exponent, I'm going to abbreviate the word negative with a minus sign, means the same thing as the reciprocal of the base raised raised to the same exponent with the sign with a positive sign. Okay, so for example, if I had 3 to the negative 7th power, that would be equivalent to the reciprocal of the base, which would be 1 over 3, to the positive 7th power. You could also take it the other way. What if you had 1 over 5 to the negative 4th power? Then the reciprocal of that would be 5 to the 4th power over 1, or just 5 to the 4th power. Now, if you look at step 5, go back and look at the expressions that gave you a zero exponent. Write each in expanded form, then simplify them. So we had 7 to the 4th divided by 7 to the 4th. Times 7 times 7 times 7. 7 times 7 times 7 times 7. Each of these 7s in the numerator cancels out with each of these 7s in the denominator, and we're left with 1. Because anytime you divide one thing by itself, you know you get 1. If we take a look at x to the 5th, x to the 5th divided by x to the 5th is equal to x times x times x times x times x divided by x times x times x times x. Each of those x's cancel out with each of those x's, and you're left with 1. So if we compare our answers from step 5 and step 1, we can come up with something about what a base raised to a 0 exponent means. So what that would mean is a base raised to a 0 exponent is always equal to 1. Again, a base raised to a 0 exponent is always equal to 1. And I went ahead and abbreviated the word equal with an equal sign. So what we're going to do now is we're going to use what we've learned about negative exponents to rewrite each of these expressions with positive exponents in only one fraction bar. So if we look at this, we have 5 to the negative 2nd over 1. We would rewrite this as with the reciprocal of that, which would be 1 over 5 with and then after we have the reciprocal, we would have a positive exponent. So instead of negative 2, it would be positive 2. Letter B would be equal to the reciprocal of 1 over 3 to the negative 8th, which would be 3 over 1, and the 8 would be raised to the 3 would be raised to a positive 8, because after you take the reciprocal, your exponent becomes positive. Now, if you look at this last one, you have 4 times x to the negative 2nd power divided by z squared times y to the negative 5th power. So what we do here is we look at what we have. The 4 has a positive exponent, so it stays where it is. The z squared has a positive exponent, so it stays where it is. The x to the negative 2nd power has a negative exponent. We know when we have a negative exponent, we take the reciprocal of that. So instead of being x to the negative 2nd power, it's going to be 1 over x, so the x goes into the denominator, and then you have to change the exponent to a positive 2. And finally, you have y to the negative 5th. If we take the reciprocal of that, so we have 1 over y to the negative 5th. If we take the reciprocal of that, it would be y, and then to the positive 5th power. So that would be what that expression would look like. Essentially, you take the variables that have negative exponents and you move them, if they're in the numerator, you move them to the denominator and change the exponent to a positive number. If you have it in the denominator, you move it to the numerator and change the exponent to a positive number. So in step 8, it says, in one or two sentences, explain how to rewrite a fraction with a negative exponent in the numerator or denominator as a fraction with positive exponents. And again, all you're doing is move the term with negative exponents in numerator to denominator and change to positive sign, and then move term with negative exponent in denominator to numerator and change to positive sign. Now, the following table supports what you've learned about negative exponents and zero exponents. If we look at this, to go down the table, you have to divide by 3. So 27 divided by 3 gives you 9. 9 divided by 3 gives you 1. And notice as you divide by 3 each time, the exponent decreases by 1. And in order to continue this pattern of dividing by 3, what you notice is that when you divide by 3 here, 3 divided by 3 is 1. The exponent decreases by 1 and it becomes 0. So it shows you that when you have, so that sort of shows you visually why the 3 to the 0 power equals 1, because you're dividing by 3 each time. In order to continue that pattern, 3 divided by 3 is 1. Then, as the exponents become negative, the base appears in the denominator with a positive exponent. Okay, so again, 1 divided by 3 is the same as 3 to the negative first power, because you'd have to switch that into the denominator based on what we know about negative exponents, and it becomes 1/3. 3 to the negative second becomes, that's the same as saying 1 over 3 squared. Well, that's equal to 1/9. We know that 3 to the negative third power would be 1 divided by 3 to the third, which is 1 over 27. And as you place these on a graph, what you notice is the shape of the graph begins to take on the form of what we've seen as an exponential equation. Okay? So, to summarize, what we now have is that anytime where you have a non-zero value for b, and for any value of n, b to the negative n power is equal to 1 over b to the n power, and 1 over b to the negative n power is equal to b to the n power. So again, what it says is you take the reciprocal of what has a negative exponent, and then you change the exponent to a positive number. And finally, anytime that you have a number raised to the 0 power or an expression raised to a 0 power, it is equal to 1. So we're going to use the properties here to rewrite each expression without a fraction bar. So we have 3 to the 5th divided by 4 to the 7th. So to rewrite this without a fraction bar, what we would have is we'd have to take the 4 to the 7th and move it to the numerator. And in order to do that, what we would have is 3 to the 5th times 4 to the negative 7th power. 25 divided by x to the 8th, we want to get rid of the fraction bar, so that means we need to move the x to the 8th to the numerator, so that would be 25 x to the negative 8th. Here we would have 5 to the negative 3rd power times 2 to the 8th power. And finally, we would have 3 times 17 to the 8th power times 17 to the negative 8th power. And if we look at that, 17 to the 8th times 17 to the negative 8th, we can use the product property of exponents. And so we the multiplication property of exponents, which means we add those two exponents, which means we get 3 times 17 to the 0 power, which is 3 times 1, so this is equal to 3. Now, we can also use negative exponents to look back in time with increasing or decreasing exponential situations. So, Solomon bought a used car for $5,600. He estimates that it has been decreasing in value by 15% each year. If his estimate of the rate of depreciation is correct, how much was the car worth 15 years ago? So, what we do is we have to write an equation. So our equation for this situation would be y equals 5,600 times the rate at which his car is depreciating, so 1 minus 0.15 to the x power. We can rewrite that as 5,600 times 0.85 to the x power. So this is our equation. Now we want to know what the value of the car was worth 3 years ago. So we don't want x to be 3, we want x to be negative 3. So 5,600 times 0.85, because 3 years ago would be minus 3. So what that gives us is y is approximately $9,118.66. So 3 years ago, the car was approximately $9,118.66. Now, if the car is 7 years old, what was the original price? Well, we know the equation for right now. The car is $5,600. We know the equation for the value of the car is that right there. So we can take that and we can say that x is equal to negative 7, because that is 7 years ago. And so if we look at that, that would tell us that if we type that into our calculator, that the cost of that car was $17,468.50. So we now know what the original cost of that car was. So that is an example of how you can use negative exponents to find the value of something or the amount of something in the past. Now, finally, we can use negative exponents to write numbers that are really close to 0 in scientific notation. So, in this example, we're going to convert each number from scientific notation to standard notation, or vice versa. So here we have this example. It says a pi meson, an unstable particle released in a nuclear reaction, lives only 0.000000026 seconds. So if we wanted to write that in scientific notation, remember we'd have to have it in the form a times 10 to the nth power. A has to be between 1 and 2, so we would need 2.6. So we'd have 2.6 times 10, and then we would want to move the decimal back 1, 2, 3, 4, 5, 6, 7, 8 spots. So we'd have 2.6 times 10 to the negative 8th power. If we look at example B, it says the number 6.67 times 10 to the negative 11th is the gravitational constant in the metric system used to calculate the gravitational attraction between two objects that have given masses and are a given distance apart. What we want to do is we want to write this in standard notation. So we'd have, so what you have is 6.67 times 10 to the negative 11th. That means we need to move the decimal place 11 spaces to the left. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So our answer would be 0.0000000000667. Finally, the mass of an electron is 9.1 times 10 to the negative 31st power. I'm not going to write all that out, but what you would do is you would move decimal place 31 spaces to the left. And we don't need to do that. That's clearly a lot more extra work that we need to do. Now, if we look at this, these three summary questions, what do negative exponents mean? So that means that 1 is being divided by the same base to a positive power, so the result may be quite small. All right, 1 is being divided by the same base to a positive power or exponent. Why does a non-zero base with 0 exponent equal 1? Because it is the division property. So it says that the 0 exponent means a power is being divided by itself. So the power is divided by itself, and anything divided by itself equals 1, equals 1. And how do negative exponents contribute to scientific notation? It just allows us to write really, really small numbers in scientific notation. So if we're going to do these quick examples here, rewrite each expression using positive exponents. This would be 1 over 3 squared. This would be x squared. This one's a little bit trickier. You need to distribute that negative 2 to each term inside this parentheses. So you have 4 to the negative second power times x to the negative 6th power divided by x to the negative second power. If we look at this, we have, if we go through this, we have 4 to the negative second power, then times x to the negative 6th divided by x to the negative second. So you'd have negative 6 minus negative 2, which would give us negative 4. So you have x to the negative 4th power. And to write this with positive exponents, we'd have 1 over 4 squared times x to the 4th, which we could say is 1 over 16x to the 4th. Finally, it says write this in scientific notation. That would be negative 2.3 times 10 to the 1, 2, 3, 4, 5, 6th, negative 6th power. So go ahead, begin working on the homework. If you have any questions, message me on Remind, email me, or feel free to ask questions during the next class.